Well, hello everybody. We're going to be talking about 6.17c polar graphs, specifically how to graph equations using polar coordinates. So this would be, I know it says theta here, but basically it's y comma x theta comma y or x comma theta y, and this is r comma theta. And so what happens when we put similar graphs on both? And it says to use Desmos.com. So we're going to go ahead and jump over to Desmos. Jump over to Desmos and take a look at these graphs. So first I have y equals 6 times the sine of 2 theta. I set my window to go from negative 2 pi to positive 2 pi by clicking on the wrench. And I've counted by pi fourths. And then I can switch back and forth to polar grids here. You can see that it's not perfectly circular and rectangular grids there. So let's go ahead and turn on the first one. So this is number 1, the one you're supposed to do first, and that's its basic graph. It looks very normal in this type of grid. We've got an amplitude of 6, a period of pi, because the 2 in there dividing into 2 pi, and this is what we get. So that's pretty basic. We're used to this graph, and we shouldn't have any trouble with the first one. So if you look down at number 2, you have this graph. You look down at number 3, you have this graph. So we can see the shift, and our midline is up here at 2, amplitude of 4, and so on. So the question is, how strange does it get when we push this? So I'm going to go ahead and switch to polar grids and do my best to make it square. So I'm going to go negative 2 pi to 2 pi, and then do the same on the other axis, 2 pi to 2. Which looks terrible, so let me undo that. Negative 6. Okay. Let's see. There. What is 2? Let's try that. That looks like a circle. Let's go ahead and turn this graph on. And so what we have here is a 4-petaled flower. It has a technical name. I can never remember what it is. But it has a 4-petal flower. And as you graph it, it starts at 0. And you'll notice down here it says from 0 to 2 pi. If I went to pi, I would only get half of the graph. So 2 pi gives me the whole graph. Because what's happening is it makes this petal. So like if I only go out to pi halves, it only gives me 1 petal. When I go out to pi, I get both petals. When I do 3 pi halves, I get 3 petals, because it's graphing this petal in the first, and then it's graphing this petal, and then this petal. And then when I take it back to 2 pi, it graphs the whole image, because it does each quadrant as it does pi. It's a pretty interesting thing. So go ahead and do your best to copy this into your notebook. What it looks like, you'll notice that it's the deep petal is on, this is where pi fourths is. So between pi sixths and pi thirds is where the petal is reaching out to, and it goes around in the loop. And then over here we have the same thing, but it reaches out to the 6th circle because of the 6 in front. So very quickly, if I was to change that to a 5, it would go out to the 5th petal. If I changed it to a 10, we can't see it, but it went out to the 10th petal, 10th row, and so on. 1 gives me right just that first radius inside. So go ahead and see what you can do. If you need to pause the video now, it will be a good time. When you're done, I'm going to go ahead and continue on. So just really quickly to compare, we have our basic sine wave versus this flowery thing. So next we have 3. So the difference here between these two equations is I've changed the inside function to an odd number. So we have that. It changes our period fairly quickly. Going back to the rectangular grid, we can see our period is now 2 pi thirds, because we took 2 pi and divided it by 3. Switching back to polar coordinates, we're going to go ahead and turn this one back off and look at what happened. So we actually get less petals, and it only took pi to graph this. So if I do pi halves this time, see how it's doing this, and it started here and it hasn't finished. So it's actually graphing, I believe, in pi thirds each quadrant. It's completing it in pi thirds. So this one, to get 2 petals, I would need 2 pi thirds. And to get all the petals, I need 3 pi thirds or pi. And I get every petal as it goes around. And so it's out to 6 still, but I just have 1 petal in and 1 on the x-axis below. So I've got 1 petal in the first quadrant, 1 petal in the second quadrant, and 1 petal on the x-axis between the third and fourth quadrants. So in comparison to this one, let's turn this one back off. This has a petal in each quadrant. They're perfectly centered in the quadrants, whereas this one has basically taken the polar plane and broke it into thirds and given me that, whereas this one broke it into fourths, which is interesting since this number is smaller than that one. So those are that. Now we have, again, let me turn this back on. Make sure you get this copied into your notebook. Do your best. Again, pause the video if need be. And then we'll move on. So we have this graph here, which has been shifted up, turning back to the regular grid, shifted up to with a midline of 2 and an amplitude of 4. It's very basic. Nothing else has happened. And so it doesn't seem like it's going to be very fancy. Going back to our polar coordinates and turning this off, our next graph is going to be, it looks like this. So it has, you scroll down and it took 2 pi to create it. It has a little loop in the middle and then an outside loop. And it just kind of tracing back what happened. Pi, so it's actually starting here on 2. So, and then in pi it is that. And so the other loopy part happens at the end. So when I get in the last, so if I just go, so let's put 2 pi over here, and let's put pi on this side. So this part happens at the end, whereas if I do the whole area, I get that. So we call this, I believe it's called, I don't know what this is called. They, again, all have fancy names that I can't remember. But that's what's happening. And so notice that theta is not being multiplied by anything. If it was, we get crazy things like that. See how we got this 2? We end up with this bow tie looking thing, or maybe a butterfly might be a better explanation, some sort of bug. And that happened because of the plus 2. So if I take the plus 2 off, I just have a circle. And if I put the 2 in, see how I'm back to where I was. So because I've added to the equation in the front, that's why I'm getting this offset loop. It's very interesting. So take a minute. You'll notice that the top of the curve is at 6 here on the y-axis going vertically. And then the loop inside is at 2. And so that's kind of where you're trying to head. See how the distance between these two is 4? And that's where the 4 is showing up. And the 2 is showing up here. It also showed up that we actually started out here at 2, made this circle, then looped inside the circle. Okay, so take a minute to draw that. And then let's jump back and see what else we're being asked to do. So we were asked first to draw them. So again, you should have copied them into your notebook. If you need to back up the video to do that, go ahead. What we want to know about how polar coordinates change the graph. And of course, there's a difference. And what do you notice? So go ahead and take a minute to answer these questions. I can't answer. What do you notice? Because I notice lots of things that you might not. It asks me what you notice. And then this is what I want you to kind of focus on. Pause the video here. I want you to, before, of course, to play. So you want to go in and set up an equation with r equals sine of theta something. You can try cosine, see what happens, and see what's happening when theta is being multiplied by an even number, and then see what's happening when theta is multiplied by an odd number greater than 1. because when it's 1, we just get a circle. And then play with what happens with addition, etc. What I want you to come away knowing is what is happening, how do the graphs change with the even numbers versus odd numbers, changing R, the radius in front, the multiplier, the amplitude, basically, what happens then. So take, I don't know, several minutes to play around, and then when you are finished playing around, then I would like you to try to graph this one without using Desmos. If you can't, that's totally fine. This will be extra credit on the exam that we're about to give. And so if you figure it out, great. If you don't, that's totally fine. Go ahead and play for a little bit, and I will have the answer for you. I'm going to use Desmos to make it, but I'll have the answer for you after. So pause, play, look around, try this, then start the video again. Okay? Okay, so we're back here, and let's go take a look at Desmos and see what I was able to create. So I have 2 petals in quadrant 1. They're fairly skinny. And then 1 in quadrant 4, 1 on the x-axis, 1 in quadrant 3, and then 2 petals here. You'll notice the symmetry around the x-axis, the y-axis, and no symmetry going this way. And what's happening, we've got 4 petals above the x-axis, 3 petals below. Whatever you can come up with is great. I hope you remember to go out to 5, and I hope you had figured out that there were going to be 7 petals. It's just a matter of what's happening. I also hope in your play that you've been able to figure out that whatever the number is inside when it's even, that there is always double that number. It's easier with 4. When it is odd, it is always the exact same number of petals as the number. Even gets us double. Odd gives us single. Okay? We'll talk more when I see you next week. Please also check Remind for your reviews. You'll get physical copies on Monday. Thanks. Bye.